Have you ever had sleepless nights about whether you're going to be able to meet the time and budget commitments that you've made on a single project, or maybe a complete portfolio of tens of programs, hundreds of projects, and maybe thousands or even hundreds of thousands of tasks and activities? Or maybe you are just concerned about where the highest leverage points are if you were under pressure to do more projects faster with the same or less resources. If you have been worried, if you have had sleepless nights, I get it. We know that 70 to 90% of all projects are either late and or over budget, and that number has stayed almost the same despite of all the advancements that we've seen in project management knowledge, as well as project management and optimization technologies out there over the last few decades. Hi, my name is Dr. Alan Barnard. I'm CEO of Goldratt Research Labs. And over the next 10 minutes or so, I'm going to do a quick introduction of why it is so easy to make time and budget commitments that under real world conditions, and real world conditions, we mean the kind of VUCA, right? Volatility, uncertainty, complexity, constraints, and ambiguity of objectives. Under those real world conditions, why is it so easy to find out that the time and budget commitments that we've made are simply not realistic? And secondly, to introduce you to a powerful new technology, something myself and my team at Goldratt Research Labs have been working on and testing vigorously over the last 5 years or so. A new technology that combines the power of dynamic simulation models with optimization engines together with AI as well as human intuition. So let's get started. For this demonstration, I'm going to use a very simple project. It's much, much simpler than probably the projects that you are managing, but it will show that even in these simple projects, it is really easy to make time and budget commitments that are not realistic. Either way, they could be too long or too short. So this is the sample project plan that we're going to be looking at. It's a condo construction. It's made up of 4 phases: design, condo construction, services and landscaping, and finishing. And as you can see, the construction and services can be done in parallel. The total time on the critical path that has been marked in red is 120 days. And the question is, how confident would you be to commit to 120 days? The teams that you're going to be working on, they have done this before, so you should have high confidence that the estimates that they've given you are quite reliable. Now the question is, well, what if you also ask them not just for the estimated duration, but you ask them for some more information? Tell me what's the best case or the minimum time it could take, what's the likely and what's the max. Now you can see this additional information suddenly makes us question whether this 120 days is a good number to move forward to as a time commitment. In the best case scenario, we can complete the critical path in 60 days. Worst case, it would be 160 days. What time are you going to be committing to? Do you still feel confident that 120 days is the right time to commit to, and that time is what we should be basing our costing and budgets on? And of course, the one element we haven't shown is, what about resource constraints? Yes, we've shown the critical path, but what is the critical chain? So we can see that in that Gantt chart, the more detailed Gantt chart there, we have walling contractors that are both required for doing the internal walls of the condo, but also the external walls. And they are kind of done in parallel. We have only one of these teams allocated to every condo project, so they can't do those tasks in parallel. So we're going to have to resolve the resource contention first. And when we do that, we will find out that we are going to be getting a different estimate. As you can see from this chart now, we had the resource contention. So we've had to resolve that resource contention, and we've gotten a new estimate. This critical path, which is now called the critical chain based on theory of constraints, where we've resolved the resource contention, is now going to be 132 days long. Our best case scenario is 66 days. Our worst case is 170 days. And again, how confident are you to commit to that 120 days? Well, this is the typical challenge that we have when we are managing these complex projects. We know that there's variability. We know that there's uncertainty. We know that there's probably constraints or resource constraints that weren't fully considered during the planning phase. and yet we have to make reliable time and budget commitments. What I'd like to do is let's just amp up the volume a little bit and say, what if your construction company had 5 teams, 1 team per project, but you've decided to make sure that the teams never wait for work, that you're going to be assigning 2 projects for every team. Now, we know that the difference between the planned days and the minimum days is about 50%. So it's 60 days versus 120 days. So there should be enough buffer or slack there to allow 1 team to work on 2 projects without it impacting it significantly, the total time it to take. And the logic makes sense, is that if there's a delay on one project, they've already been allocated the other project, they can quickly move over. And if there's no delays, we'll get them to say swap once a week. So we can show progress in both of them and recognize the revenues on both of them as quickly as possible. And the question is, again, how confident are you that if you launch these 10 condo projects in parallel with your 5 teams, you'll be able to deliver them in 120 days, or maybe worst case 130 days, if that's what the critical chain is going to be like. Well, that's where our new technology comes in. We've called it the Project Portfolio Digital Twin, and this has been designed from the ground up specifically for these type of complex project environments, where it's critical that we make reliable time and budget commitments, that we can quickly check if we can do better by just changing the rules. How much better could we do if we decided to use different rules for planning and execution? Or if we did have the ability to add bottleneck resources, how much faster can we go compared to the cost it will incur? Or if we find out that we've got surpluses in our non-bottleneck resources, we reduce them, how much cheaper can we do the project? And lastly, we can also use this technology to identify the impact, both operational and financial, of unplanned events, maybe scope changes on the customer side or supply delays on the input side, and then how best to mitigate that. So the next few minutes, I'm going to quickly show you a demo of how this Project Portfolio Digital Twin works. It starts off with step 1. There's only 5 steps in the process. Step 1 is loading the data. So the data in this case will be an export of the full work breakdown structure, like I just shown you, from your existing IT system. And the only thing that we're going to be adding to that work breakdown structure that contains the single project you want to simulate or a whole portfolio of programs that you want to simulate is that randomness, an estimate between the best case, worst case, and likely case for each of those task durations. And then you can also add in any unplanned events that you are expecting that you want to simulate the impact of. So that's going to be step 1, is just loading data. It's already sitting in your IT systems. As we load the data, it instantly builds a complete digital twin or simulation model of your environment, whether it's for a single project or a whole portfolio of multiple programs that are made up of tens of projects, hundreds of phases, and maybe thousands or even hundreds of thousands of tasks and activities. So let's load up the data, and when we go to step 2 shows us the data that we've just uploaded, to review it, to come up with some questions or hypotheses that we want to check. That in step 3 we're going to be setting up the scenarios to run those hypotheses. Step 4 will be actually running the simulation, and then step 5 will be reviewing the results and making decisions. So we can see in this dashboard a quick summary of the portfolio. 10 projects, as we've mentioned, all condo projects, identical. They all have planned durations of 120 days. We plan to start them on the 4th of January, plan to complete all 10 projects on the 4th of May. The question is, will we be able to do that? The financial side shows that each of these projects will generate $1.2 million of revenues, and there's an expected net profit of $312,000, about 26% margin, which would be a very nice net margin to make. We can see the project plan summary. Those are Gantt charts at the project level, so you can see there's our 10 projects all done in parallel. 2 projects per team. We have the 5 teams, and that's what we see in our resource planning side. We have 5 teams that is used to complete one of these projects. As we scroll down there in terms of utilization, we can see the highest utilization is our walling contractors at about 60%, and then the next one is designers at about 53%. That's the average utilization over that 120 days, but there are periods where they are overloaded. So we can zoom in. First of all, let's look at the project plan summary. We can see a great amount of details there. You can zoom in to show it at the task level, and those red boxes are identified as the critical path that determines that project and portfolio duration plan of 120 days. Let's close this up and let's zoom into our resource planning side. This will show us a loading on across all resources, and we see we have a lot of surplus capacity. There's a small little spike there somewhere in the middle where we are getting close to the maximum. But when we zoom into a specific resource like that walling contractor, let's select a walling contractor, we can see that the walling contractor is not utilized at all in that beginning part or at the end part. But in this middle part, the first period we require up to 10 walling contractors. We have only 5, remember? And then there's that part with the overlap where we require up to 20, and that's where our 360% utilization is coming from on that part. So the question is, well, will this just balance up? Because we've got a lot of surplus and slack here. Will it just, be done without major delays because of this bottleneck? So let's close this up and we go to the third step, which is essentially setting up our scenarios. I've already set up 4 scenarios here. Scenario 1 is going to be just baseline scenario. We going to be simulating the project as they are planned, 10 projects planned in parallel, and the teams are going to be multitasking, so they'll switch every week between the 2 projects, and every time they switch, there's a bit of a switching cost, which is about a 20% time that they lose while they're switching, figuring out where they were. Scenario 2 is going to be the same as scenario 1, but we will ask the question, what if there's no task switching, no multitasking? We're giving each team only one project to work on. If that project is delayed, they must just wait for the delay to be resolved, and then they keep on working, but we are not forcing them to switch between projects every week. We want to see how much better you can do just by stopping the multitasking. Scenario 3 is where we're going to be deploying a critical chain project management algorithm to resolve the resource contention. So probably we're not going to be launching all 10 projects at the same time. We'll launch 5 and then the next 5 based on our capacity constraint, which is likely to be the walling contractor, but we'll also check it for the designer because that has a very high utilization as well. And in scenario 4, we'll keep on using critical chain to reschedule our portfolio. But in this case, we will allow a project to grab more resources if they are available than what was planned. So maybe the project had a plan to use 1 designer, but when that task became due for, say, project 7, and there were 2 designers available, we will allow it to grab both designers to get the task done faster. And now the question is, what is going to happen? We're going to be going to step 4 to actually run the simulation, and I'm going to go from my slideshows to the actual simulation model so you can see the action. So we're going to first run scenario 1, which is our baseline scenario. And remember, what we're trying to do here is we're trying to check whether that 120 days, or maybe more conservatively, the 132 days would have been a reliable time estimate. And we're going to be running 100 replications. We can easily run hundreds or even thousands to see what is the range of outcomes that we're going to be getting. And you'll see these bars are representing every time we complete a project, it shows us how long did it actually take. We're monitoring the mean and also the standard deviation. And you can see from the early results here, we're now 50% done in modeling these 100 replications. It shows that we are likely going to be over 200 days on average with a standard deviation of around 9 or 10 days. And that's not good. Remember, we were targeting a $300,000 profit. At the moment, it's showing a loss of over 300,000, which again is not good. And partly because it's taking us not 120 days on which the budget was based, but it's taking 200 days. So our operating expenses is going to be more. Plus, we are going to be incurring some penalties for late deliveries. So this is not a great scenario. Now, you can imagine if you've done this type of portfolio before, let's say you do 2 of these a year, each of them taking about 120 days. After the second time that you've done it, and it again took about 200 days to complete, you're probably going to be updating your commitments from 120 to 200 days at a minimum. And even then, you might still be a little bit late from time to time. But at least you're going to be updating your costs, so hopefully you won't lose so much money. The question is, can this digital twin of ours show you if you could do better just by changing the rules? And firstly, the first rule is, what if we just stop the teams from multitasking? Do only one project before you start the second one. That's going to be scenario 2. So let's run that and see what will happen there. And immediately we can see we are getting down to about 180 odd days to complete the project portfolio. So that's a substantial improvement, about a 25-day saving. And let's run the others because we can run them in parallel using the multiple cores of my laptop computer here. We can see that by using critical chain, we're getting from 180 down to about 150. That's a dramatic improvement. And our profitability has gone from minus 360,000 to minus 150 to now plus 150. And then the best result is where we also allow the utilization of additional resources. So we're not pre-allocating our teams to each project. We're essentially keeping the resource pool as an aggregate central, and we dynamically allocate it based on which project need those resources today. So let's just sum this up. We'll get back to our simulation to just highlight some results. So going from 200 days down to 126 just by changing the rules. Going from an average project duration, that was the duration for the portfolio. This is for each individual project of 180 days down to 93 days. Average cost per project from 140,000 down to 100,000. This is just purely the wages. Of course, it doesn't include all the equipment hire, materials, etc. Our average bottleneck utilization, very interesting, has gone up from 34% up to almost 50% on that walling contractor and the designer. And net profit has gone from minus 30% to plus 21%. And a very important number is we would have lost sales of about 800,000 on this 1.2 million revenues because of the delays. We couldn't start new projects earlier. So I hope that was useful. This is essentially the power of our project portfolio digital twin. It can show us what the impact will be of what Deming called common cause variability, which is essentially variability in the task duration. It can also show us the impact of special cause variability, which is unplanned events, scope changes, additional tasks that have to be done, or supply delays. But it can also show us how much better we can do just by changing the rules. And then what we didn't illustrate here is what if we added some additional walling contractors? How much faster can we go? Or those resources that turned out not to be bottlenecks, we probably have quite a bit of excess there. If we reduce that excess, how much cheaper can we deliver this project? If you want to learn more about this new technology that we are very, very exciting to introduce to the market, or you want to book a demo, perhaps even do a demo with your data, you're welcome to go to projectdigitaltwin.com. Thank you for your attention.